video game mechanics can really look complicated. Between all of the different jumps and slides and shoots and pushes and abilities, it can be pretty overwhelming and sometimes you don't know where to start. Well, we're going to go over how you can make any mechanic. Starting with a classic, the Mario mushroom block, where Mario jumps up, hits the block, and something pops out. This is a pretty good starting example, because it doesn't look terribly complicated, but if you think about it, there's a lot of things going on that you might not notice. So on the surface there's Mario who punches a block, and it bounces, and then something spawns out of it. But what does that mean? If you were going to make that mechanic yourself, how would you do it? Once you've got what's happening listed out, you can then break that down further. And the idea is to go from the concept and whittle your way down to the actual mechanics in the game. So the jump, for example, where Mario jumps up and punches the brick, is a collision. But you need to specify that Mario is jumping and that this block is being hit. So it's not a basic collision, it's two conditions together that result in something like a collision. So this is probably a point above Mario that's checking to see if it's inside that block, while Mario is jumping. And then next is what happens when the collision is done. The block bounces and spawns something. So the bouncing is probably just a tween, but then how does the game know that there's something inside the block? And how does the spawning happen? And that can be done in a few different ways, but one of them is probably a variable inside the block that tells the game what object to spawn. So it could create that object based on the variable, and then apply a tween to it to make it go up. So this seemingly simple example of a mechanic, if you try to tackle it as just hit a block and something spawns, you're missing all of the little tiny details inside, and it'll just be more complicated to tackle. So that's the premise of this whole thing, is that you need to look at it as a series of tiny mechanics inside of the bigger one. So next, let's talk about something like Tetris. Or not actually, because that's way too complicated. This is one of those games that looks simple, but isn't really. How about Flappy? No, too easy. Final Fantasy, turn-based combat. Let's talk about that. Well, from the outside looking in, you've got the player's turn and the enemy's turn, they've got health, and you've got a button to press. So let's hop over to this example really quick inside of GDevelop. This idea will work for basically any game engine, but we're using GDevelop because this is the GDevelop channel. So here in this little example, I have the player, an enemy, health, and a button. And for logic, there's the player side of things, the enemy side of things, and the things that happen outside of turn order. And so to break down something as complicated as turn-based combat into manageable chunks, we need to first talk about what turn-based combat is. And basically it's just my turn, my turn, your turn. And that's basically just a Boolean variable. So we can add a variable to the beginning of both sets of logic, and make it so that the player can only do something on their turn, and the enemy will do something on their turn. But only when the Boolean says that it's their turn. So if it's the player's turn or not. And then we need them to do something. So as the player, I'm going to press the button to attack the enemy. So if I click the attack button, we need to attack the enemy, which is basically just dealing damage to their health, showing it to the player, and then letting them react. So for health, both objects need to have a variable called health. And then when you click the attack button, we need to take it away from the enemy. So we'll take away 1. And then we need to display that on screen. So now when I press the attack button, they lose health. It's pretty straightforward when you break down how the things work, and think about the individual parts that need to happen in order for the player to be able to attack the enemy and for them to lose health. But then the enemy needs to react to it. So usually that would involve some object shake and a hit flash to tell you that they got hit. So how would that work? Well, you give the object a hurt animation so they can play it, and change their animation to hurt, as well as shake the object. Then the enemy needs to be able to attack back. We need to switch the Boolean to the enemy's turn, so switch it to false where it's no longer the player's turn, and then once their hurt animation is finished, allow them to attack the player back. And that's basically just the same thing we're doing to the enemy, but back at us. So we can copy the player's logic down and use that, but swap everything out for the player instead. And then just like the enemy needs to wait for their hurt animation to be finished before they can attack back, because otherwise it would be instantaneous, and that's not usually how these games work. We'll make it so that the player can only attack when their animation is back to idle again after they've been hurt. And now you can see that the player is attacking the enemy and the enemy is attacking back. And now we just need them to die. And that's going to be one of the things that happens outside of the turn order, because it doesn't need to be the enemy's turn for them to die, and if there's multiple enemies and players, then this could be happening in either turn either way. So now if the enemy's health is equal to or below 0, we'll set their animation to death, which means their hurt animation won't ever finish, and they won't attack back. And there they go. And that's it. Something as complicated as a JRPG, if you break it down to its individual pieces, is much easier to tackle than just trying to look at the whole thing as one giant piece. If you'd like to see more videos like this, where we give advice about game development through the lens of GDevelop, then be sure to check out this video, because it's really not that hard to make good games. Fail faster, succeed sooner. If you genuinely want to make the best game you possibly can, this should become one of your core beliefs. These words should be playing on loop in the back of your mind every day. Fail faster. No idea you have is perfect, and no game you make will be either. So you need to put your ideas and concepts to the test. Approach game development with the attitude of a scientist performing experiments. Start by coming up with an idea for your game, create the smallest possible version of that game, or the MVP, the minimal viable product, and then get that MVP in front of players or other game developers to see what works and what doesn't. Don't be defensive when you get this feedback, and don't make excuses for any of the flaws in your game. The game isn't you, and their feedback isn't a reflection of your skills as a designer. They're just a reflection of the current state of the game you're working on. It's not only okay to fail at this phase in development, but it's actually really good. Because now you won't build your game on top of a bunch of bad ideas and misconceptions about what players actually want. Only through getting player feedback and being willing to change your game's design will you be able to create the most engaging game possible. If you never show anyone your game before you release it, then you'll never know what other people might enjoy about your game. And you may spend the entire development of your game focusing on elements that nobody else really cares about. If you launch a game made with GDevelop, with your feedback settings turned on, then you can collect and manage feedback from players directly in the engine. But you can also just approach people directly and ask what they think of your game. Or publish your game with a form for people to fill out to get their feedback that way. Fail faster. Understand that ideas are cheap. Basically everyone in the games industry, or those aspiring to create games, will have a handful of genuinely cool game concepts floating around in their head. But only the games that actually get made matter. So don't spend dozens of hours trying to come up with the perfect game idea before actually starting to build one. The best games become popular, not the best game ideas. For example, some of the most popular games in recent history are just, what if enemies attacked while building your Lego set? What if Chuck E. Cheese was horrifying? And what happens when you put 100 people in a small map with guns? If you have any idea for your game, just start building it. Because only then can you start to iterate on your idea and find out if the game could be successful. Fail faster. Starting with an MVP definitely helps, but you can even start to fail well before you've gotten that far into your game project. Try writing down your game idea, as well as the mechanics and concepts, and then share that with people you know, or other game developers in the GDevelop community. But make sure to frame it in a way that they'll actually be honest with you. Tell them that you're looking for brutally honest feedback, and then try your best not to react negatively when they give you that feedback. Even though it's going to suck, try reacting with as little emotion as possible, and just say, I'll write that down, or I'll take note of that. So then they're not afraid to be honest with you. This is how games go from being terrible, to being fine, to eventually becoming great. If it works for the kind of game you're making, obviously this won't work for a platformer, but try mocking up the game with pen and paper so that you can try playing it with people before you've sunk a bunch of time and energy into its development. And just fail faster. Once you've built your prototype, it's tempting to think that adding more mechanics, better art, environments, or sound effects will help make the game feel better. But a lot of that is really just noise that will make it hard to figure out what's wrong with the core of your game. So send your prototypes out into the world, check your analytics, and try to figure out why your game might have a high bounce rate, or why players aren't playing the game for as long as you hoped. Get feedback from as many people as possible, from everywhere you possibly can, and then sift through that feedback to try and find common themes and insights into what actually resonates with players. You can try posting your various development builds on GD.games, itch, and other game hosting platforms, but even just sharing your game's progress with video clips and screenshots on social media can help gauge interest in the different elements of your game. You can also try advertising your game as it gets closer to being finished with a boost, to share your game with both the community and with ads run by GDevelop on platforms like TikTok and other social media channels. But just remember, fail faster, succeed sooner. If you're interested in more game design and marketing videos similar to this one, then click on one of these. Hey there, my name is Helper Wesley, and today I'll be showing an advanced way to save and load your game. In the last video, Max explained different kinds of variables. And in this video, I'm going to show you how to use that to save all of your variables at once, and then load them back into the game with 3 simple actions. So to begin with, I'm going to show you what we're saving. If I go to Global Variables, you'll see that I have a structure set up here already, with the parent variable here on top, and the children variables below. To create a structured variable like this, just click Add New Variable, and click on the wrench icon to the right. And then from the drop-down menu, select Structured Variable. From there you have a parent variable, and you can add children by clicking on this button here. But we don't need that for now, so we'll get rid of it. I already have the event set up for this example, so if we go into the event sheet, you'll see that I have it broken up into save, load, and reset. The save, or write action, is all that's required for saving this. If we open this up, you'll see that it's actually write a text, not write a value. And for this action, we need to make up a storage name that makes sense, and then a group name that makes sense. And this will determine where external to the game this text will be saved. And then to grab the entire structure instead of a single variable, you just type in the variable type that you need, in our case global variables, and you'll see it there in the autocomplete. Click on that, and then type in the parent variable that you want to use, in our case score. And when we select that, the expression is then complete. And that's all we need to do for saving. Loading, or reading, requires 2 actions. The first one being read a text, which will grab the text from the external file that we saved it in earlier. Make sure that we give it the same storage name and group name so it knows where to grab the file from. And then because things are read back into the engine into scene variables, we've made a temporary scene variable that I just called temporary variable. So when this action reads or loads in the text, it will be put into the temporary variable first, as a string. And the string will look like this. And then we need to use the next action to break that text apart and put it into the proper variable slots. Convert JSON to a global variable. And you can do this for object variables and scene variables as well, but we're just doing global ones. The JSON string that we use is the temporary scene variable that we filled in the last action, and if you don't know how to type it in, you can click this button to the right to search for that. And then finally we want to select the parent variable to tell it where to put this newly broken up text. The reset is just deleting the external storage, setting all the scores to 0, and resetting the temporary value. Now let me show you the example. if I press these buttons here to the left, the score will go up. And then if I press save, we'll be saving that structure, which is the parent variable and all of its children, into an external file. And now if I change the scores to be something else, and press load, first it will read that external file and put it into the temporary scene variable as a place to hold it. Then it will parse or break apart that string of text and put it inside the global variable that we had selected, which in this case is scores. You can see down below what the text string looks like. If I change the scores again, press save and then load, you'll see it changing. So to go over it one more time, you've got write or save the global variable structure that we want into a JSON string, and then read that JSON string into a temporary scene variable to hold onto it, and then finally parse or convert, if you're searching in engine, the JSON string from that temporary scene variable into its parent variable, so it gets sorted into the children variable slots that it's supposed to go into. Doing it this way means that you can literally make one parent variable and have all of your game's global variables, or scene variables, or whatever, children of that one parent. So you can have the most complicated variable system ever, and as long as all of them are children of the one top parent variable, you can save and load everything in, just like I did in this video. As always, be sure to comment down below with any kind of tutorials that you would like to see next. I have been Helper Wesley, and I'm glad I could help. Have you ever wondered how you could build a bunch of objects into a scene, like in a city builder game or farming game, leave the scene, and come back and they all still be there? I'm going to show you the simplest way that I could come up with. There are more robust ways of doing this, but I find this to be the simplest one that's the easiest to understand. So here I have a little game example where I can place buildings, save it, get rid of them all so they're gone, and then load them back in. And that's all being done with just these little events. And the reason that I like this setup is because I can add whatever I want to it and still have it work. So if I wanted to add the angle of all objects, for example, I could just add the action to the save section to save the angle of all objects, and then when loading, slot it in right here to change the angle of all objects, and then change this value and this value, because now there are 4 things being saved. Now to show you that the actual angle is working, I'll just put these in here. And to show you how flexible this is, I will also add another object called building. Add that to the project, put it into the scene, angle it, and then go to all objects, the group, because these events are using all objects, the group. So I'll just add that to the group, and now it's there. It's there. I will save, delete, and load. And everything was saved in that array and then loaded back in. So to show you how to set this up, I've actually created a blank version of the same scene. So the first thing I need to do is add a group called all objects. And in global variables, this is already set up. This is an array variable with no children. All right. And so we have all objects with the large building and small building in the group. And let's get started. So the first thing is I need the save and load buttons. And I'm going to be checking back to the other event sheet just to make sure I'm not doing anything wrong. And the first thing we're going to want to do is add a for each object event type. And we'll go for all objects, the group. So now this event will repeat for every building in the scene. And then we'll look up arrays, global arrays, add a text variable to the array, and we'll look up object name. And we'll use all objects in this event. So this is going to save the name of all objects to the array save all objects. And let's just make sure this is working properly first. So we'll go to preview with the debugger, refresh, global, nothing there, place a building, place 2 buildings, save, refresh, and there we go. But we need to add the next action because if I keep pressing save, it will just keep adding to that array. So the next action is this one. Clear array. And we want to do it for global variables and for this array. Cool. So now when I do it, save, refresh, global, 3, but next time I press save, refresh, it's all the same because it's clearing them before adding in the new variables. So it gets rid of the old ones before adding new ones. And then we need to add a number variable to an array. And the number we want to add is the X position of all objects in the all object group. And we'll do the same thing for Y. And now place it, save, refresh. There we go. We have the name for large building and the X and Y, and then the name for the other large building and the X and Y. Now to load them in. For this one, we're going to use a repeat event type. So not for each object, but just repeat. In here, you can typically write in a value like 20, and it'll repeat 20 times. But we're going to use a variable. And this time we're going to use global variable child count and use save all objects. So that's our global variable for the array, and this will repeat for the number of children variables in this parent variable, which means it's going to repeat for every child under the array. But we don't want it to do that. We want it to repeat for every 3 variables, because 3 child variables represents 1 object right now. In this case, it's 4 because we're saving 4 things per object. In this case, it's just 3. And then we want to create an object from its name. And again, we're going to go all objects so we can use the group instead of having to use an individual object. All right. So for this, we want to use the first variable in the array. So we're going to type in save and get the save all objects array. But you can't just use the array. You need to tell it what number. So we're going to type in 0 for now, and then do the same thing, but 1 and 2. There we go. This is the name we saved. This is the X position we saved because it's the second number. And this is the third number, and that's the Y position. So we're going to create an object with that name at the X and Y position in the variable. So let's try that. Put it into the game, save, refresh, check the global variables. We got the large building, the X position, the Y position. We delete it. Delete, gone, load. There it is. But if we have multiple objects, it's not going to know what to do with them. Save. Because we're only using 0, 1, and 2, and then beyond that, it doesn't know what to do. So now's where we need the climb variable that's in here. So we're going to change a number variable for a scene, and we're going to add a variable. We're going to add climb variable, make it a number, climb, set to 0. So it starts at 0 every time. And then at the end of that, every time it repeats this event, we'll add 3, because each object is represented by 3 different variables. And then we'll divide this by 3. So it only repeats after every 3 variables are checked. Set to. Add 3. But before this will actually work, we need to change the 0, 1, and 2 to use the climb variable. So I'm going to remove the 0, type in climb variable. There we go. Same thing for 1. But we use climb variable plus 1. And then the same thing for 2. But we'll use the climb variable plus 2. So it'll be 0, 1, 2, and then the next time it repeats, it'll be 3, 4, 5, repeat, 6, 7, 8, repeat, and so on and so on and so on and so on. So now let's preview that. Place, 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 save, delete, load. And that's it. And just like shown in the earlier example, you can add whatever you want to in here. You can add animations and then slot that in right here above the climb variable and adjust this value and this value to represent how many things you're saving per object. Now, you might want to do something a little different with this, where this actually happens at the beginning of scene. So when you walk out of and into a scene, things can be loaded back in the way they were when you walked out. But ideally, for a lot of things, you'll want to save that array with all the variables externally. So when this saving is done, you'd want to save a text, and then at the beginning of the scene, load a text, like that. But to do this properly, you need to save the entire array. So if you want to learn how to do that, check out this video. There have been a number of comments asking for an inventory tutorial. And so this little video series will go over the process of setting up an inventory system for your game with one of the ways that you could do it. And so if this one doesn't work for your game, you can check out the inventory example game or check out this community extension. But let's start off by setting up this one. Let's go over what's already in the game. So we have a sprite object for inventory slots, another one for inventory icon, and it has animations with the same animation name as the objects in the game. And then there's inventory text, which will be the number that's displaying the quantity of the object. And then we have the objects that you can pick up: wood, meat, and gold. So we'll start by placing the inventory slots into the game scene, and then we'll give them a variable called slot number. And then in the properties panel, we'll change that to 0, 1, 2, 3. Then we'll add a global variable called inventory and make that a structure, because we're going to save the information in a structure and then use that structure to display what's in the inventory. Now in the event sheet, under setup inventory structures, we're going to set up an event at the beginning of the scene and a sub event that will repeat for each object. And we'll set that to inventory slots. So it will repeat 4 times, because we have 4 different inventory slots. Then we'll change the variable value of inventory, but we're going to modify it a little bit. So in GDevelop, if you try to add a variable into a structure in a place that doesn't yet exist, that variable will be added to the structure. It doesn't need to be declared. So inside the inventory, we're going to have a slot, and then what we put inside of that slot. And in this case, we'll start with the name. And for the slot, we're going to use that variable that we added to the inventory slot object. We'll type in inventory slot, slot number. And when you type in the variable like this, there is no autocomplete, but you'll know if you got it right or not, because the action isn't showing an error. If I removed one of these letters and clicked away, it shows that I've done it wrong. And then we'll set this to a text because it's the name, so it's going to be a string, and we'll set it to empty. There we go. Now, if we open the debugger and check the inspector, we can go to global variables and see that in our inventory structure, we have 0, which is the first inventory slot, and inside of that slot is the name empty. And then for 1, it's the same thing, and 2 and 3. So that's 0, 1, 2, 3. And then next, we'll do the same thing, but we'll add quantity. And we'll set this to be a number variable and set it to 0. And now again, in the debugger, you can see that the 0 slot has the name empty and the quantity 0. So far so good. We've got the structure set up and we're ready to start adding things to it. So next we're going to go back to the game scene and open up the object group panel and create a new group. We'll call this items and add all of the items that we want to be able to pick up into that group. And then inside this variable section, we're going to add a variable for quantity and set it to 1. And then when I press apply, all of these objects now have that variable. So all of these have the variable quantity 1. And you can use that to determine how many of the thing are in that stack. Save periodically. Then next, inside of the pick up items from ground section, I'm going to add the condition to check if the player is in collision with the items group. And next, I'm going to create an external event. We're going to go to external events, create a new one, and call it add item. And we're going to link that up to the existing game scene and add an event. And now buckle in for this next part because we're going to search through the structure to check for any empty slots and then put our item into it. So to begin with, we're going to add a local variable called valid space found and make it a Boolean that's false. Then as a sub-event, we're going to add another local variable, call it slot number. So that will be the slot that we're looking for to see if it's empty. And then we're going to add another event that will repeat. And we'll make it repeat based on the number of children inside the inventory structure. So right now we have 4 inventory slots, so we'll make it repeat 4 times. But we'll do that by typing in variable child count, and then type in inventory. Now we'll add another sub-event, and inside this sub-event, we'll check to see if the slot is empty. So we'll check for inventory, slot number, name. So we'll check the name inside of the slot. Make sure it's text, and check to see if it's equal to empty. So now if the slot's name is empty, we'll trigger these actions. We're going to change the variable, steal this one so we don't have to write it again. And so we're going to set the name to the text equal to the object's item name. So if we pick up the wood, it'll be wood, and if we pick up the gold, it'll be gold. Then we'll do it again, but this time for quantity. And we'll open the action and change it to a number and set it to the item's quantity. Because again, inside the object group, items has the quantity variable, so we'll set it to this number whenever we pick up an item. Then, outside of this event, we'll change the variable slot number, so this local variable up here, by adding 1 to it. And so this is going to loop through the structure to check and find empty slots. And then finally at the end, we'll delete the item. So now that we're this far, we should test to make sure this works. So we're going to go to Game Scene Events, and when the player collides with the item, we're going to add Link to External Events. So we're going to put this as a sub-event, and add item. And the reason we're doing it this way rather than having it just in the event like this, is because you might want to add items to the inventory in ways other than just running into them. So now when the player runs into one of the items, it will add item. So let's test it to make sure it works. So with the debugger, we've got our structure here, and if the player runs into the meat, it gets deleted, and if we check, this first slot was given meat. So the name is meat and the quantity is 1, because each object has their quantity set to 1. So now this slot holds meat with 1, but we didn't tell it when to stop adding slots. So if I scroll down, you'll see that the second slot, number 1, also has meat, and the third slot, number 2, same thing, and same thing. And so we have to go back here, and this original local variable, valid space found, is going to make it so it only happens once. So we're going to copy this, change the variable to valid space found, and make sure it's set to false. Then we'll add another variable action here for valid space found, and set that to true. So now in order for this event to trigger, valid space found has to be false, but the first time that it triggers, it will change the variable to true. So it happens once, and then it can no longer happen again. And then we need to add valid space found to the delete action, because if you don't find a valid space and your inventory is full, you don't want to delete the item. So now we'll try it again. With the debugger, check our structure, run into the object, refresh, and you'll see that meat is here, and not here. This one's still empty, and so is this, and so is this. Only the first slot got filled, and the rest are empty. If I go pick up the other objects, the wood and the gold, and then refresh, you'll see that meat is still in the first slot, because it got skipped over when I picked up the next item. Wood is in the second slot, and then gold is in the third slot. So this is just part 1 of this tutorial series, so if that video isn't out yet, be sure to subscribe, or just click on this video. This is the second video in a series about making an inventory system. In the last video, we made it so that you can pick up an item and put it inside of a structure, and now in this video, we're going to make a custom object for your inventory slot, and make it so that you can display those custom objects to show what's actually in your inventory. So great, we've got the structure set up, and we can add items to that structure. Now we need to be able to see them actually in the game. And to do this, we're going to use something that is a little bit new to the engine. We're going to make a custom object or smart object. So I'm going to take the inventory icon, which again has the images saved as different animations, with a name for the animation that's the same as the name of the object. I'm going to take the inventory text and drag that into the scene, because these two things will make up the display that you see for the inventory. But in order to avoid managing two different objects and linking the text to the icon, we're going to put them together into a custom object. So I'll select an instance of both objects, right-click, go to Extract, and Extract as Custom Object. Create a new extension. I'll call it Inventory Icon Display, and I'll call the new custom object just Inventory Icon. And I'll remove the objects from the scene list to avoid any confusion. And when I do that, I get to see the visual editor for the custom object. So this is a screen just for that. And if I go back to the game scene, I'll see this is now one object. And I'll change that back to Inventory Icon. I can go back to the visual editor by right-clicking on the object and going to Edit Children. And then from here I can build the object, but if I want to give it logic, I need to go to the extension editor, which also opens up when you create the object. And now from here there's a lot of different options, but just focus on what I'm doing. So I have the object selected, Inventory Icon, go to Properties, and I'm going to add two different properties. One for the name of the object, which is a string, and then another one for the quantity, which is a number. So now this custom object, or smart object, has name and quantity as properties of the object. But in order to actually interact with those in the game, I need to click here in the property and generate expression and action. And when I do that, it'll give me a new expression and a new action to use. So this is the action. And if I go to the game scene event sheet, I can click on Add an Action. And for the inventory icon, scroll down and find Name. So I've made a new action that I can use with this object. And you can see that I can set it to a value. Now, back inside the extension editor, I'll go back to the object and property, and then do the same thing for quantity. Generate expression and action. So now there's an expression and an action. So I've got an action to set the name and the quantity for the custom object. And those are the two things that we want to display with our inventory. But using one of those actions would just change the property inside the object. It wouldn't actually do anything to the object. So inside of set name, we're going to change the animation by name of the inventory icon and set it to, using an expression, value. So when the action triggers, it will change the name to the value I put in that action, and then use that value to change the animation of the inventory icon. And then I'll do the same thing for the text object. I'll change the text of the inventory text to equal value. So when the set quantity action triggers, it will change the quantity to value and then set the text to that value. Again, the one that I use in the action. So let's do a quick test to make sure that it works. So for the inventory icon object that we just made, we'll go to name and we'll set the name to gold. And then we'll set the quantity to 100. So now when we put the cursor over the object in the game, it will change the name to gold and the quantity to 100. So back in the game scene, we have this inventory icon object in the game. And if I preview it and hover the cursor over the object, those actions trigger and change the animation and text to gold and 100. So now we have a working inventory icon that later we'll be able to drag around and do things to. But for now, we're just going to set it up so that when we add an object to the inventory, we create one of these icons to show that we've picked it up. And so to save time, we're going to duplicate add item, because there's some logic in there that we want to copy, and we'll change the name of this new external event to update inventory. And then we'll open it. And what we wanted was this section here, where we use a slot number and repeat through the structure, but instead of changing the variables, we're going to use it to create the icons. So if the inventory slot is not equal to empty, so there's something there, we'll go back to the game scene. We'll grab these actions. We'll set the name to the inventory structure slot name, because if it's not empty, there must be a name there. So we'll set it to that name, and we'll set the quantity to that inventory slot's quantity. And just like before, this is going to loop through the structure until we're done repeating because we're out of inventory slots. But before we're done, we're going to add another event that actually deletes the inventory icons. And so whenever we update the inventory, we're going to start by deleting all of the existing icons and giving ourselves a blank slate to work from. And then we will create the inventory icon at the X and Y of the inventory slot. But nothing in this event yet is picking the right inventory slot. So we'll check the inventory slot's variable for slot number and check to see if it's equal to the slot number that we're checking through. So we'll check to see if the inventory slot's slot number is the same as the local variable slot number that we're cycling through. And now we're almost done with displaying this. We need to go to the project manager, go to global variables, add need inventory update, and we'll leave it as false. So we're going to toggle that whenever we need to update the inventory, like whenever we add, remove, or update something. So we're going to check the variable need inventory update and check if it's true. And if it is true, we're going to set it to false, so it only happens once. And then we're going to link the external events for update inventory. So now when we need to update the inventory, we'll set it back to false, but also trigger this external event. So that will trigger all of these inside. And now the last thing we need to do is set up a trigger for this event. So we'll copy this action, go to the add item external event, and then right here, when valid space found is true, so we know the object found a spot inside the inventory, we'll set need inventory update to true. So then it's being set to true inside this event, and then the next event checks for it and updates the inventory. So let's preview the game now and see what happens. So if I walk into an object, you'll see the old one got deleted first, and then the new inventory icon was created in the first slot. Then if I walk to the next object, it's in the second slot, and then in the third. So in the next video, along with moving objects around in the inventory, we're going to show how to allow objects to stack. Because right now we're checking for empty slots and not slots that exist with the same name, so they don't actually stack together. And now, be sure to click on this. This is the third video in a series where we're making an inventory system. And to prevent the series from going on for another 3 or 4 videos, we're going to put everything into this one video with less editing, so buckle in and get ready to start. So last time, we made it so that we could pick up the objects and put them into inventory slots, but we don't allow them to stack. So the next thing we're going to do is make it so that you can pick up the items and let them stack. So in the add items section, or external event, right now we're checking to see if it's equal to empty. And it would be nice to be able to just put in or as the condition to go for empty or the same name as the object you're picking up. but the OR condition breaks object picking, so it wouldn't work in this case. So what we're going to do is copy the original logic and use this first one to see if you already have it in the inventory, and the second one to see if there's an empty slot. So what we're going to do, instead of checking if the name of the slot is empty, is check to see if the name is the same as the item's object name. So the items group, the things that we're picking up off the ground, we're going to check for the object name. And this is really the only difference between the two. In this setup, if you've picked up one that you already have, it goes into that slot, changes valid space found to true, and so this one doesn't work, and it doesn't check for an empty slot. And then because the valid space was found, we update the inventory and delete the item. But now that we're adding it to a stack, instead of just setting it to a value, we're going to change the quantity to add to the item. So now when we preview the game, we have the gold bag, and when you walk into it, you get 1, and if you walk into another one, you'll get 2, instead of them being on 2 different stacks. Then, we're going to add a global variable and call it original slot number. And we're going to use this to drag and drop the inventory. And so now in the game scene, we're going to go to the inventory icon and add the variable slot number. Because then when we're dragging this around, we can keep track of which slot it was originally from. And then we'll give it the draggable object behavior. So then in the event sheet, we'll add a section for drag and drop. So then we'll check to see if it's being dropped. So if the inventory icon was dropped, then we'll do a couple things to it. So firstly, we'll check to see if it's dropped into the game. So we're going to check to see if the cursor is not touching the inventory slot. And we can't use just an inverted condition because there are 3 of them, so it's not going to be touching one of the inventory slots by default. So we'll use the not condition to make sure it's not touching any of them. And then we'll create an object from its name. So we'll use the inventory icon, and for the name, we'll use the inventory icon's name property, the one that we made and added to it. So we'll use the X and Y of the cursor as the place it gets dropped to. And so then we'll change the quantity variable inside of the item to equal the quantity of the inventory icon that we just dropped. And again, that's the quantity property that we made. So now when we drop it, we'll check to make sure we're not touching an inventory slot with the cursor. And then we'll create the object based on its name and give it a quantity based on the quantity of the inventory icon. So let's preview that. Pick one up, it's a 1, drop it. You can see that there's 2 there, and I can drag it and drop it again, and drag it and drop it again. And if I pick those up, they'll get added to the inventory. But that's not what we want to have happen. What we want to happen is for the inventory icon to also get deleted, and for that amount to be actually taken out of the inventory. So what we're going to do is add another external event, call this one remove item, and then in here, we can steal these, the actions to change the variable based on the slot number. But since there's no local slot number variable, we're going to use the original slot number, the global variable that we created earlier. We'll set the quantity to 0, and the name back to empty. And then we'll change the need inventory update variable to true, so that it updates the inventory. Now in the event sheet, after we've dropped the object, we're going to add link to external events, and remove item. There we go. But because we're using that original slot number variable, we also need to add another event to check if the inventory icon is being dragged. And if it is, we'll change the variable original slot to equal the inventory icon's slot number. So when you pick it up to drag it, you'll be using the slot number inside the object, but we haven't yet set this number. So when we update the inventory and create the object inside the inventory slot, we're going to change its variable slot number to equal slot number. So when we create the object using the slot number to cycle through the slots, we'll change the variable number to equal the slot number it was just created with. So then in the event sheet, when we drag it, we can set the original slot number as a variable outside of the object in order to know where it was originally from. So now, after all of that, if we preview the game, pick up the object, take it and drop it, the inventory was updated, which means that it was deleted when the inventory updated. So now there's 2 inside of that object. So when I pick it up, I apparently made a mistake in the video. Apologies for that. This should be items. Among objects items, so the items group, create an object named inventory icon name. So using the name saved inside the inventory icon, we create an object from the items group, which are these 3. So now, after all of that, if we preview the game, when I pick up a gold bag and drop it on the ground, it creates one of those objects. It's again 1. If I pick up another one, it'll be 2. If I drop that, now this has 2 in it. If I pick up this one, it's 1. And if I pick up this, it will be 3. And I can do that with all the objects. And now the last thing we need to do is set it up so that we can move things around in the inventory. So we'll create another event, make it a sub-event of was dropped. So it's another thing we're going to check when we drop the object. Call this one dropped into inventory slot. And to make sure that the inventory update is happening at the end of the event sheet, I'm going to move this event down below it. That way all of these changes will happen, and this will be the last thing it does. So now, if we drop the object, and our cursor is touching an inventory slot, then we'll create another external event. And this one will be called Move Inventory Icon. And before we begin this one, we'll just link it here as well. Now move inventory icon. So what we're going to do first is just move it to an empty slot. So we'll go back to the add item external event, steal these 2 again, and we're going to change the inventory slot's number based on the inventory slot in the game. So when we go to drop the object into a new slot, we'll use that slot's number to know where we're dropping it in our structure. And what we'll set that to is the inventory original slot number's name. So when we pick up the object, we'll get the original slot number saved separately, and we'll use that slot number to know what we're moving over to the next one. So we'll do the same thing for the second one, but this will be quantity instead of the name. And then at the end of this sheet, we'll set need inventory update to true in order to update the inventory. And I think if we did just this part and previewed it, we'd get that. But if I drag this into another slot, we'll duplicate it. So right now we're just adding the information from one slot to the next, but not removing this slot or swapping them. We'll copy these events, make this one for the old slot, make this one for the new slot, if we set the name to empty and the quantity to 0, and instead of the new slot number, we use the original slot number, and then we made sure that these are set to, because we're not adding to it or swapping to it. So then if we preview the game now, pick up some gold, drag it from one slot to the next, the first slot will be set to empty and 0. So we can drag them back and forth between slots, or drop them on the ground, and pick it back up. And there we go. Now, the last thing to do is make it so that we can swap between two different slots that already have things in them. And to do that, we need to hold on to the one being swapped to and keep it separately. So we'll create some local variables because we're only going to do it right here, and call it original name and original quantity. Original name will be a text, and original quantity will be a number. And so we'll copy those two events again, and change the original name to the original slot number name, and the original quantity to the original slot number quantity. Whoops, I have these backwards. What we're going to do is save the values of the original slot here separately, and give the old slot information from the new slot. So whether it's empty or if there's something there, we're going to take that information and put it in the old slot. And now this separately saved information will go into the new slot. So we'll set this to equal the original name and the original quantity. And there we go. Now we preview the game. This should work. Let's get two separate ones. We have 1 and 2. Can drag them around. And if we grab one and put it into the same slot as another one, it'll switch. But even with an empty slot, it's still switching the information. It's just switching empty and 0 instead of gold and 1. Now, you can expand on this inventory system as much as you want to. If you go into the Add Item section, you can check not only if a slot has the same name, but you could also check to see if that inventory slot has a certain number. So if you want them to stack until 10, you just add a condition to check if the inventory slot's quantity, as a number, is less than 4. Is less than or equal to 4. And we'll set that as the cap. So we'll check this, and if it's less than or equal to 4, then it will add it to this stack, but otherwise it'll go here. So let's try that out. So now we have 5. If we pick up more, it'll go to the next slot. And they'll also swap like before. But if you understand how this works, you can tweak it to fit basically any kind of game that you want. But ideally, this will be used for something like Stardew Valley. But remember, if this inventory system doesn't work for the kind of game that you're building, there are some extensions that you could use that might work for you instead. Did you know that you could use JavaScript in GDevelop, the no-code open source game engine? JavaScript is the most popular programming language in the world. And while there are several different languages used inside the engine for various components, we can actually use JavaScript to build our games. So here I have a little game scene, and what I want to do is make the ambulance object move to the right. Simple enough. So I can go to the event sheet, and you can see I've already got it set up. Using the no-code system, it's just as easy as if at the beginning of scene, then add to the ambulance a permanent force of 150 pixels per second along the x-axis. And that will get us to move along to the right. So if I preview the game, you'll see the ambulance coming along and going down the road. Now, for transparency, here's the camera controls, adjusting the camera's position at the beginning of scene, and then changing the camera's rotation to look at the ambulance based on where the camera is. But we're going to focus on this event here. I'm going to remake this event using a JavaScript block. So first I right click, go to add, and then add JavaScript code. This will give me this block. And in here I can type out JavaScript and do whatever I want. So I will disable this event, so it's not triggering anymore, and just use the JavaScript to do the same thing. Firstly, I can select the object to pass through as the argument of this JavaScript block, and in this case it'll be the ambulance. And then I can write out this line of code to make the ambulance move to the right, where the object is having a force applied to it, 150 in the x, 0 in the y, with 1 as the multiplier. And then we can preview the game and get a black screen because the event is wrong. So you can turn on your developer tool just like you would in a Chrome browser, and you can see the errors piling up. So let's exit that. And I actually already have this written down in my handy little notepad, so I can see what's wrong with the event by checking my notes. And it looks like I forgot to include the S for objects. But we also want to add the at the beginning of scene. So we'll take this entire piece of code here and paste it in. So if runtime getTime manager is first frame, so at the beginning of scene, then apply the force to the object. And we'll preview the game. And there we go. The object is moving to the right, the exact same way that it was with the no-code actions and conditions. And that's because under the hood, the no-code system is really just a cleaner and more natural way to present JavaScript code. These no-code events are being translated into JavaScript when the game runs. This, though, is not actually the best way to use JavaScript with GDevelop. The best place to use JavaScript is inside of extensions. Extensions can be found here in the project manager. You can either create your own, or use one of the hundreds of extensions already created for the engine. In this case, I've installed the Gamepad extension. So I can go here to the extension, click to edit, and open it up in the editor. And you can see right away, here's the JavaScript for the extension. Now, you don't necessarily need to use JavaScript inside of extensions. You can also use the actions and conditions already in the engine. But for this extension, the actions and conditions required to use a gamepad controller just didn't exist. And so JavaScript was needed to make this work. But you can create new actions and conditions and use them alongside the no-code event system. So now that this extension is installed, I can go back to the event sheet and under conditions, look up gamepad, and there's a series of conditions here that weren't there before. So now I'm able to check inputs from the controller, whether it's connected, the type of controller, the buttons that are pressed, and so on. So writing with JavaScript inside of an extension is a good way to keep all of your code for a specific feature neatly packed away in one place, and allowing you to continue using the cleaner and more naturally read no-code event format. Writing your JavaScript code inside of an extension also allows you to transfer that from project to project or share it with other developers. If you would like some more learning resources for using JavaScript in GDevelop, the links to those are in the description. But if you are new to GDevelop and want to learn more, then check out this video.